Imagine building like a 35-ton, 80-foot-long biological machine, right? You show it to the world, and then the scientific community just flat out tells you it never actually existed.
Yeah, which is exactly what happened.
Right. So welcome to the deep dive. Today we're looking at a huge stack of sources. We've got dense scientific journals, historical encyclopedias, passionate Reddit debates, and some pop culture archives. And they all center around a creature that you definitely know.
Oh, absolutely. Our mission today is to sort of trace this wild journey. We're going to uncover the chaotic history, the scientific erasure, its cultural immortality, and then this highly improbable triumphant resurrection of the thunder lizard.
Yeah, the thunder lizard. So I want you to close your eyes for a second, unless you're driving right now, in which case, please keep your eyes on the road. But think about your quintessential childhood image of a dinosaur.
Like the classic toy you had. You're almost certainly picturing this massive gray-green creature with, thick tree trunk legs, a body shaped somewhat like a blimp, and this remarkably long neck stretching up into the treetops.
Exactly. Chances are you are picturing the Brontosaurus. And what we want to do today is figure out why this specific dinosaur captured our collective imagination so fiercely, and why practically everything we thought we knew about it was turned entirely upside down.
It really is, it's one of the most dramatic sagas in the history of paleontology. And to understand how this massive creature could simply vanish from the scientific record, we have to travel back to the late 19th century American West.
Right, the Gilded Age.
Exactly. And more specifically for our sources today, it was the era of the Bone Wars.
The Bone Wars. I mean, just the name sounds like a gritty HBO drama. We're talking about this ruthless, incredibly bitter fossil hunting rivalry between two really prominent, wealthy paleontologists, Othniel Charles Marsh from Yale and Edward Drinker Cope from Philadelphia.
Yeah, and the American West at this time was essentially a lawless frontier for fossil hunters. And honestly, Ruthless doesn't even begin to cover it. These two men exhausted their personal fortunes trying to outcompete, out-publish, and basically publicly disgrace each other.
No, it was so petty.
It was. They resorted to bribery. They hired spies to infiltrate each other's dig sites. They would even, this is wild, they would use dynamite to literally blow up their own excavation pits once they were done, just to ensure the other guy couldn't come in and scavenge any remaining bones.
Wait, really? Dynamite?
Yeah, dynamite.
Which is just an absolute nightmare for modern science. Imagine blowing up a pristine Jurassic fossil bed just out of spite.
It's horrifying to think about now, but this intense toxic competition meant they were pulling fossils out of the ground at a frantic, breakneck pace. They were hastily throwing names on fragmented skeletons just to claim the discovery first.
Got it. And that brings us to 1877, when Marsh describes a new dinosaur from Colorado. He calls it Apatosaurus ajax, which translates to the deceptive lizard.
Right. And then, just 2 years later, in 1879, Marsh's team is digging at a different site called Como Bluff in Wyoming. They uncover a massive, fairly complete skeleton of a sauropod, which is the scientific term for those long-necked, long-tailed, plant-eating giants.
The blimp bodies.
Exactly. So Marsh rushes to publish his findings, and he names this new specimen Brontosaurus excelsus, the noble thunder lizard. He genuinely believed it was a completely different beast, larger and much more robust than the Apatosaurus he had found 2 years prior.
Okay, let's unpack this for a second. Because Marsh's rush to publish created a monumental problem. The 1879 Brontosaurus skeleton from Wyoming didn't actually have a head.
No, it didn't.
Right, and skulls are notoriously fragile, so they easily detach from the neck after the animal dies. Finding a headless skeleton isn't that uncommon, but Marsh wanted a complete, spectacular display for his museum. So to finish it, he essentially created a fake. It's like rushing to patent a groundbreaking smartphone,
Right,
but slapping a toaster part on it just to get it out the door.
that is a remarkably accurate analogy. Marsh was desperate to have the most impressive display in the world, so he grabbed a stout, boxy skull from a completely different excavation area, Quarry 13, and stuck it onto the Brontosaurus skeleton, which came from Quarry 10.
So he just hoped nobody would notice.
Pretty much. And to make matters worse, that skull didn't even belong to a closely related dinosaur. It actually belonged to a Comrosaurus, or possibly a Brachiosaur.
Oh, wow.
Yeah, so Marsh created an anatomical chimera, a literal Frankenstein's monster made of completely mismatched parts, and he presented it to the world and to the scientific community as a factual biological reality.
But his Frankenstein monster couldn't hide forever. Eventually, other scientists started looking very closely at those bones, and they realized something was deeply, fundamentally wrong.
Exactly. Fast forward to 1903. A paleontologist at the Field Museum in Chicago named Elmer Riggs decides to rigorously examine both of Marsh's skeletons side by side, the Apatosaurus from 1877 and the Brontosaurus from 1879.
And when he's looking, he's not just looking at the size.
No, not just size. He's looking at the joints, the fusion of the vertebrae, the overall development of the skeleton.
He's looking for signs of aging.
Precisely. Riggs realizes that the Apatosaurus skeleton had unfused bones. That is a clear indicator of a younger, immature animal still in its growth phase. The Brontosaurus skeleton, however, was heavily fused and robust.
Oh, I see where this is going.
Yeah, it wasn't a different species at all. The Brontosaurus was just a fully grown, mature Apatosaurus.
And this is where the strict, unforgiving rules of scientific nomenclature kick in. In paleontology, the first published name always gets priority. It's the law of the land. Since Apatosaurus was published in 1877, 2 years before Brontosaurus, the name Brontosaurus was officially declared a junior synonym. It was tossed out. The creature formally became known as Apatosaurus excelsus.
According to the scientific record, the Brontosaurus simply ceased to exist.
It's just wild how a name can be erased on a technicality like that. I mean, it's like finding out Clark Kent and Superman are the exact same guy, but the strict rules of journalism dictate that because you met the reporter first, you can only ever call him Clark Kent from now on. Superman is dead.
That's a great way to put it. And the scientific community completely agreed with Riggs. From 1903 onward, the consensus was clear. It was an Apatosaurus.
But wait, if the scientific community killed the Brontosaurus in 1903, why did I have a plastic Brontosaurus toy in my bedroom in the 1990s? Think about how wild this is for you listening. You might have grown up with a favorite dinosaur, completely unaware that the scientific community considered the very toy you were holding to be a 100-year-old typo. Why didn't the public get the memo?
Well, this raises an important question. If the science was settled, why did the name survive? It points to a massive, fascinating disconnect between scientific consensus and public museum exhibition. And the main culprit behind this disconnect was the American Museum of Natural History in New York and its formidable president, Henry Fairfield Osborn.
Right. In 1905, the museum is preparing to unveil the first ever fully mounted sauropod skeleton to the public. It is a massive deal. And Osborn stubbornly, just flat out refuses to use the correct Apatosaurus name. He labels their spectacular new mount Brontosaurus.
Yeah, our sources, specifically a really deep historical dive on Reddit, highlight that Osborn was driven by a rigid, dominant vision for his museum. He wanted a massive, aggressive-looking dinosaur to fit the imposing, powerful aesthetic he was pushing at the time.
Like a PR move.
Essentially, yeah.
Yeah.
To him, the thunder lizard with a heavy, boxy skull fit that specific agenda perfectly. Deceptive lizard just didn't have the same ring to it. So he insisted on keeping the incorrect Camarasaurus skull on the mount because it looked tougher, and he kept the Brontosaurus name on the placard.
Here's where it gets really interesting. By ignoring the science and keeping that name on the placard, Osborn accidentally birthed a pop culture titan. The Brontosaurus became this sort of scientific zombie. It was dead in the academic journals, but it was incredibly alive in the public consciousness.
It instantly became the archetypal dinosaur in early media. In 1914, Winsor McCay used it as the star of his groundbreaking animated film, Gertie the Dinosaur. It was the centerpiece of the 1925 silent film, The Lost World.
Oh, and King Kong.
Yes. In the 1933 cinema classic King Kong, it's a giant brontosaurus that aggressively chases sailors through a misty swamp.
You literally could not escape it. Sinclair Oil adopted Dino the dinosaur, a bright green brontosaurus, as their corporate mascot in the 1930s. And let's not forget the beloved 1988 animated film The Land Before Time. Littlefoot is explicitly called a longneck, but all the promotional material and public understanding recognized him as a brontosaurus.
Exactly. And this tension between public adoration and scientific accuracy eventually reached a boiling point in 1989. The U.S. Postal Service released a beautifully illustrated set of dinosaur stamps. And right there, alongside the Tyrannosaurus and the Stegosaurus, was a stamp proudly labeled Brontosaurus.
Oh man, and the paleontology community absolutely lost their collective minds over this.
They were furious. Prominent scientists accused the federal government of fostering scientific illiteracy. They argued it was a slap in the face to a century of established research. But the Postal Service firmly defended the stamp. They argued that the name Brontosaurus was simply more familiar and culturally significant to the general population.
Which is incredibly ironic, considering that same USPS stamp collection also included a pteranodon. And pteranodons are flying reptiles. They're literally not true dinosaurs by any biological definition. But nobody in the scientific community seemed to complain about that. All their anger was focused entirely on the Brontosaurus.
It's true. And if we connect this to the bigger picture, it really highlights how public engagement shapes the legacy of paleontology. The public's intuition, their deep affection for the thunder lizard, preserved the name in a sort of cultural amber. They kept the idea of this specific dinosaur warm for over a century, just waiting for science to catch up with better technology.
Which brings us to the climax of our deep dive, the 2015 resurrection. And this is where the story shifts from museum politics to hard, cutting-edge data.
Right. In 2015, a massive monumental study led by paleontologist Emmanuel Chop and his colleagues was published in the journal Peerj. The sheer scale of this study is staggering. They spent 5 years visiting 20 different museums across Europe and the United States, analyzing 81 distinct sauropod specimens.
And we aren't just talking about them walking in with the tape measure. They meticulously documented over 477 distinct anatomical traits for every single skeleton.
Right. They weren't just looking at the overall size of the leg bone. They were cataloging incredibly minute details. The exact angle of a ridge on a shoulder blade, the specific curvature of a cervical rib, the depth of a groove on a tail vertebra.
Wow.
Yeah, and they fed all these hundreds of data points into a massive computer algorithm designed to map out the evolutionary family tree of the diplodocids, which is the specific family of long-necked dinosaurs that includes Apatosaurus.
And this algorithm had a very strict rule, right?
It did. They established an algorithmic threshold. If the specimens differed by more than 20% of these 477 characteristics, the algorithm classified them as a completely separate genus. And when they finally ran the numbers, the Brontosaurus passed the test.
It actually passed?
It did. The structural differences between Brontosaurus and Apatosaurus were just as numerous and just as significant as the differences between other closely related, widely accepted genera.
Okay, wait. I have to push back here. Because 20% feels like a somewhat arbitrary number. If humans and chimpanzees share nearly 98% of their DNA, how can a 20% difference in bone bumps and ridges suddenly resurrect an entirely erased species? Does a slightly curved shoulder blade or a longer groove really make it a fundamentally different dinosaur?
That is a very valid question, and it gets to the heart of how morphological taxonomy works. Remember, we don't have dinosaur DNA. We only have fossilized bones. So the researchers didn't just pull the 20% number out of thin air. They calibrated the algorithm by looking at other dinosaurs that the entire scientific community already agreed were distinct from each other, like the Diplodocus and the Barosaurus.
Okay.
They found that those distinct animals differed by about 20% of their bone traits. So if Apatosaurus and Brontosaurus also hit that 20% threshold, it means they're just as different from each other as a Diplodocus is from a Barosaurus.
Oh, okay. That makes a lot more sense. It's a calibrated baseline. So what were the actual physical differences? If you and I are standing in a museum looking at these restored skeletons, how do we tell an Apatosaurus from a newly resurrected Brontosaurus?
It comes down to some brilliant biomechanical differences. First, let's talk about the neck. Brontosaurus had 16 neck vertebrae, whereas Apatosaurus only had 15.
An entire extra vertebra.
Yes, and that isn't just a fun piece of trivia. It fundamentally changes the animal's biology. That extra bone, combined with the fact that its individual vertebrae were longer, gave the Brontosaurus a neck that was 9 meters long. Because of the leverage in the center of gravity, it could likely rear up or reach into the tree canopy as high as 18 meters.
Wow. And what about the skull? Because obviously we aren't using the fake Camarasaurus skull anymore.
Right.
Huh.
Once they digitally matched the correct, historically accurate Diplodocid-style skulls to both bodies, they found clear variations. Brontosaurus had a narrower, deeper skull. It had 15 large, robust, peg-like teeth per upper jaw quadrant, which were built for raking and crushing tough, woody conifer needles. Apatosaurus, on the other hand, had 18 slightly smaller teeth, likely adapted for a different diet of softer leaves.
And the shoulder blades were different too,
A
right?
scapule, yes. Brontosaurus possessed a uniquely curved shoulder blade that sat at a roughly 30-degree angle, with very distinct, deep depressions to anchor massive neck muscles. The Apatosaurus had a much straighter scapula edge, sitting at about a 20-degree angle, which suggests it held its neck in a naturally lower posture.
So they weren't just mathematically different on a spreadsheet. They were structurally, functionally, and biologically different animals navigating the world in totally different ways.
Precisely. Now, To maintain our objectivity, we do need to acknowledge that science is a continuously evolving debate. Our sources note that some modern paleontologists urge caution regarding the 2015 study.
Oh, really? Why is that?
Well, they point out that many of these mounted specimens in museums have been heavily restored over the last 100 years. They use plaster, steel rods, and paint, which can sometimes muddy the exact shape of the bones. So, while Brontosaurus, being its own genus, is the prevailing theory right now, the debate is still an active, living part of paleontology.
Which is exactly how the scientific method is supposed to function. It's always testing itself. But now that the Brontosaurus has reclaimed its name, we need to clear up exactly what kind of animal this 35-ton, 82-foot-long living machine really was. Because the early 20th century myths did this creature incredibly birdy.
They really did. Back in 1905, a prominent paleontologist named W.D. Matthew theorized that the Brontosaurus was a sluggish, swamp-dwelling automaton. He literally compared its dense leg bones to a deep-sea diver's boots, suggesting the animal was so hopelessly heavy that it had to live half submerged in lakes and swamps just so the water could support its massive weight.
Yeah, that's the classic image, right? The Brontosaurus chewing on swamp weed while water comes up to its chest, which we know today is completely false.
Entirely false. The physical pressure of deep water on a chest that large would have actually suffocated the animal. It wouldn't have been able to expand its lungs. The reality is that Brontosaurus was a fully terrestrial, highly active landscape engineer. And the way it supported its 35 tons of mass while walking on dry land is an absolute marvel of natural engineering.
Okay, this is the part of the research that absolutely blew my mind, the pneumatization.
What's fascinating here is how incredible it really is. To build an animal that big, nature had to get creative. Their bones were not solid, heavy rock. Up to 60% of their vertebrae was actually empty airspace. The bones were intricately honeycombed with internal air sacs that connected directly to the respiratory system.
So they were basically building a 9-meter-long neck using the exact same physical principles as a modern suspension bridge, maximizing the structural strength while ruthlessly minimizing the weight. The neck was 20% lighter than it looked.
Exactly. Without that honeycomb structure, the animal couldn't have lifted its own head. And this lightweight engineering allowed for something called niche partitioning within their habitat.
Let's explain that for a second. They lived in the Morrison Formation, right?
Yes, the Morrison Formation was a massive, ancient floodplain covering what is now a huge chunk of the western United States. Millions of years ago, it was packed with different species of giant dinosaurs. And niche partitioning is essentially nature's way of dividing up the buffet so they didn't eat each other out of house and home.
Because if you have a dozen different 30-ton species eating the exact same bushes, the ecosystem completely collapses.
Precisely. So they evolved to target different heights. You had the Diplodocus, stretching up to 92 feet long with a whip-like tail, but its shoulder structure kept its neck low to the ground. It acted like a giant lawnmower, eating soft mosses and ferns. Then you had the Brachiosaurus, which had massive front legs and was built like a vertical armored giraffe. It reached the absolute highest canopies that nothing else could touch.
And right in the middle of this prehistoric buffet, you had the Brontosaurus.
Right in the middle. With its 18-meter upward reach and those robust peg-like teeth we mentioned earlier, it was perfectly adapted to consume the tougher, mid to high-level, vegetation-like thick conifer needles that the low-grazing Diplodocus couldn't reach and the high-grazing Brachiosaurus ignored.
They weren't just big for the sake of being big. They were highly efficient, beautifully adapted biological machines that shaped their entire ecosystem through strategic grazing.
They were the undisputed keystone species of the late Jurassic period.
So, what does this all mean? If we step back and look at the whole picture, trace the epic journey of the Brontosaurus. It starts as a hastily assembled headless trophy during the bitter espionage of the Gilded Age Bone Wars. Then it gets officially stripped of its title and erased due to a rigorous scientific correction in 1903. It somehow survives for over a century, purely as a pop culture icon, sustained by museum aesthetics and Hollywood movies. And finally, it is vindicated by a modern, incredibly complex algorithm as a true biological reality.
It perfectly illustrates that science isn't a static list of facts you memorize from a dusty textbook. It is a living, breathing, constantly self-correcting process. Sometimes we get it wrong, and sometimes we realize that our past mistakes were actually right all along.
Exactly. So the next time you see a retroplastic dinosaur toy on a shelf, or you drive past a Sinclair gas station with that big green dinosaur standing out front, you aren't just looking at a nostalgic corporate mascot, you are looking at a hard-fought triumph of modern data over century-old assumptions. You're looking at the noble thunder lizard,
Right.
rightfully restored to its throne.
It's a great reminder to never count a good dinosaur out.
And it leaves us with something pretty wild to think about. If our understanding of a 35-ton, 82-foot-long monster can completely vanish into thin air and then reappear over the course of 130 years just based on how closely we measure the grooves on a bone, what other extinct ideas or entirely unrecognized creatures are currently sitting mislabeled in a museum drawer somewhere right now, just waiting for the right algorithm to bring them back to life?
It definitely makes you wonder what else is hiding in plain sight.
It really does. Because sometimes the dinosaur you imagined in your childhood turns out to be exactly as real as you hoped it was.